Hello everyone, in this video we are going to talk about a series problem. Okay, this series is given and we have to find out the sum actually, not convergence divergence. We have to actually find the sum. Okay, how much is this? Okay, and this is a tricky problem actually, and we will use two different methods to calculate this. Okay, so that you remember at least one of them, and how to, we will also see how to solve this kind of problem. This problem actually came in WBPSC 2022 recruitment of assistant professor exam. Okay, and the content is this. If you are liking the content, then please take a moment to like this video, and of course subscribe our channel to learn more and more high quality mathematics. Okay, so the given series is this: summation k square by factorial k, this is factorial k. Okay, and the sum is over k equal to 1 to infinity. Okay, we have to find out how much is this quantity. Okay, how much is this? Well, so first method. Okay, in the first method we will do simple manipulation, and then we will use some kind of analysis, let's say real analysis. Okay, so first manipulation. So sum k equal to 1 to infinity k square by factorial k, right? So this is nothing but summation k equal to 1 to infinity k by factorial k minus 1, right? Why? Because factorial k is 1 into 2 into 3 into so on up to k, right? The last element is k, and over in the numerator it is k square. So k they go away. You can just cancel them up, and then what remains is k over k minus 1 factorial, right? But then k equal to 1 to infinity, and this actually can be written as, so basically we are putting k equal to k plus 1, right? So suppose we are putting k equal to k plus 1, then k becomes k plus 1, and then k minus 1 factorial becomes k factorial. Okay, so we are actually replacing k, we are replacing actually k to k plus 1. So then when k starting from 1, initially k was starting from 1, right? Now k should start from 0, right? Because corresponding to k equal to so k equal to k plus 1. So initially this was 1, so that should correspond to k equal to 0, right? So the sum is now k equal to 0 to infinity. This is nothing really complicated, you just check it. Okay, so k equal to 1, so 1 by factorial 0, right? First term, and the second term is 2 by factorial 2 minus 1, which is 1. You just try this. K equal to 0, you put 1 by factorial 0, and then k equal to 1, 2 by factorial 1, right? For k equal to 1. So they are actually same quantity. You can just check it. It's not difficult. So then it is k equal to, sorry, this is k equal to 0 to infinity 1 over factorial k, okay, plus summation k equal to 0 to infinity k by factorial k. Okay, now you know this quantity. What is this? This is just E, right? Summation k equal to 0 to infinity 1 by factorial k, you know it, right? 1 plus 1 by factorial 1 plus 1 by factorial 2 and so on, right? This is actually E. Okay, now this for k equal to 0 to infinity, right? So I will just write it here, the terms. So first term is corresponding to k equal to 0, so it is 0 by factorial 0. Factorial 0 is actually 1. I will write it here. Factorial 0 is considered always to be 1. Okay, so 0, and then plus 1 by factorial 1 plus 2 by factorial 2 plus dot dot so on, right? So but this is actually the 0 term, right? So we can actually say that this sum is exactly equal to k equal to 1 to infinity k by factorial k, because anyway corresponding to k equal to 0 we get only 0. Okay, so the actual sum is actually from k equal to 1 to infinity k by factorial k, 1 by factorial 1, 2 by factorial 2 and so on, right? So this is this, but then this is exactly equal to, so k by factorial k, right? So this is exactly equal to, you can just write it here, summation k equal to 1 to infinity 1 by k minus 1, right? Because k they cancel each other, and u what remains is k by 1 by k minus 1 factorial, right? But then this is again equal to e plus summation k equal to not from 1, now from 0 to infinity 1 by factorial k. You can check. So instead of k minus 1, I am now writing k. Okay. So it is actually 1 over factorial k. But then this, this to infinity, oh, I have written this anyway, this, but this is again e, right? E plus, this is again e. So what becomes the answer is 2e. The answer is 2e. Now we will use the second method. Okay. So we know that this exponential x equal to n equal to 0 to infinity x to the n over factorial n, right? This is well known. This is well known. And what trick you can use is that you can differentiate both sides. Okay. So suppose you differentiate both sides, then this side is by differentiation by d dx. Okay. You get exponential x again, but on this side you get summation n equal to 0 to infinity x to the power n minus 1 n here, and then factorial n, right? Now if you multiply by x, exponential x, then you what you get? N equal to 0 to infinity n x to the power n again, and then by factorial n as it was. And this differentiation from here to here, it is doable because this exponential x is actually uniformly convergent everywhere. So now x to the x times e power x is this. Again you differentiate. Okay. Again you take d dx of this. Okay. Then you get 1 e power x plus x, derivative of e power x is e power x, and then summation n equal to 0 to infinity, so 0, you get n square now, and then x to the power n minus 1, and then factorial n, right? So this is what we have now. So this is an identity, right? This is an identity. So this is true, this identity, or you can say this equality is true for all values of x, right? So now if you put x equal to 1, put x equal to 1, what do you get? Here you get x equal to 1, so you get e x equal to 1 times e power 1, so e plus e, which is 2e, right? Which is 2e, and on this side you what you get? Summation n equal to 0 to infinity. Okay, if you put x equal to 1, it is just n square by factorial n, right? But if you remember, the actual problem was to find k equal to 1 to infinity k square by factorial k, right? But you check that if you put n equal to 0, you only get 0. So nothing adds to the remaining thing, right? So you can actually write this as k equal to 1 to infinity k square by factorial k. Writing k or n doesn't matter, right? And also n equal to 0, n equal to 0 term can be removed because it is only giving us 0. Okay. So in this way also we prove that summation k square by factorial k is actually 2e. Okay. So this is the correct answer, and this is really important even for interviews and as well as the exams. Okay. Well, that's all in this video, and I thank you for watching.